Hello, everyone. My name is Fadi Malhem, and today I am presenting a presentation on a review article titled with Effects of Beta-hydroxy beta-methylbutyrate HMB on Exercise Performance and Body Composition across varying levels of age, sex, and training experience. And it was written by the authors Gabrielle Wilson, Jacob Wilson, and C. Meninen. And it was published in the Journal of Nutrition and Metabolism in 2008. I'm also presenting this as part of my course Nutrition 701. So to start with, our outline is going to be as follows. First, we're going to go through the background, why is this significant, and then the objectives set by the authors, and how does HMB supplementation help in different metabolic pathways, future research, conclusion, and lastly, the references. So amino acids are essential macronutrients, and we have 20 amino acids, of which 3 of them are branched chain amino acids, and they're mainly leucine, isoleucine, and valine. I have also added the structure over here. As we can see, they are all branched, but the one that we are mostly interested in is leucine. And leucine has multiple roles in the human and in the mammalian body. It is very important for the metabolism of protein, glucose homeostasis, and of course the effect of insulin as well. It is very well known in exercise recovery, and it has been used a lot by athletes, as well as its metabolites and anti-catabolic properties. So leucine can be further metabolized by the body through a transaminase, and when it is transaminated, it will give us alpha-ketoisocaproate, which is called KIC, which leads to a decrease in the muscle breakdown. And then the body further works on the KIC by either in the mitochondria through an enzyme called alpha-ketoacid dehydrogenase producing isovalyryl-CoA, or in the cytosol by alpha-ketoisocaproate dioxygenase enzyme to produce beta-hydroxy beta-methylbutyrate HMB, which is our main focus. So HMB is a byproduct or a metabolite of leucine, and it has this structure, and it's made up of 5 carbons, 10 hydrogens, and 3 oxygens. And it is very well advertised as a supplement for athletes because it has an ergogenic benefit. It is also known to have an anti-catabolic effect on muscles, anabolic effect on muscles, and lipolytic effects. The measures used to study HMB supplementation are different depending on the type of research and what are their goals, but the main ones used are the isometric and isokinetic strengths. In elderly, functionality exercises are tested after HMB supplementation. Also, some form of questionnaires that study the delayed onset muscular soreness in athletes or in individuals who are exercising. And then health markers, including blood pressure, cholesterol, immune, cell function. And also we have other markers of muscle damage, including 3 important ones: lactate dehydrogenase, LDH, creatine kinase, CK, and 3-methylhistidine. And now, since we have talked about the different ways to measure HMB, the objective of this review was to have an in-depth and objective analysis of HMB research in different situations and different metabolic statuses. Also, analysis of possible mechanisms that HMB may exert its effect on either preventing muscle damage, lowering protein degradation, and as well also protein synthesis stimulation. The efficacy of HMB supplementation has been studied in different individuals under different circumstances. The first one that was done that the authors went through was the untrained individual. What is the effect of HMB supplementation on untrained individuals? And they have found out that HMB supplementation decreased plasma markers of muscle damage, including the creatine kinase and also the protein degradation 3-methylhistidine marker in a dose-dependent response. So once they started increasing the amount of HMB supplementation, it was a direct relationship. Also in the survey used DOMS in untrained individuals, and the plasma creatine kinase were decreased, as well as the range of motion due to the supplementation by HMB. However, in trained athletes, similar findings were also noticed, and HMB supplementation can enhance the lean body mass and increase the lean body mass weight, and indices of performances during resistance training were also improved, where athletes were able to do more repetitions and with extra weight load. There was also a decrease in body fat noticed in different athletes, and there was also a reduction in the markers for muscle damage, including lactate dehydrogenase and creatine kinase levels, especially in runners. And the decrease in body fat is thought to be because HMB supplementation can increase the beta oxidation of fatty acid palmitate, to be very specific, by up to 30%. Also, further research was done on in elderly and in animals. In elderly, HMB supplementation proved an increase in body fat loss. So those who were supplemented with HMB had like it's negative 0.66 versus negative 0.03, and it also proved an increase in the upper and lower body strength by 13% in those who were supplemented with HMB supplementation versus the placebo that did not take HMB by 11%. Further, in other elderly studies, limb circumference was also increased, which might indicate a bulking effect or increase in the muscle mass. Leg strength was also better, and it was tested through curling the legs. Hand grip strength were also improved, and there was an increase of up to 20% in protein synthesis in elderly from ages 70 to 77 who were supplemented with HMB. Whereas in animals, most studies were on either rabbits or rats in this review, and HMB supplementation also showed a decrease in body fat, blood cholesterol, as well as muscle proteolysis. However, what's interesting here is that HMB supplementation was found to be ineffective if exercise was not there, which leads to more or further research to investigate the effect of HMB in animals that do not do any exercise. And for the other objective of this review, it was to study the possible mechanisms of HMB action. And they were basically divided into 3 different mechanisms. The first mechanism is that HMB is going to increase sarcolemmal integrity by the conversion of HMB to HMG-CoA reductase, which will later cause an increase in the substrate for the repair and enhance the sarcolemmal integrity. So this is the first path in which HMB can affect muscles. And then the second one, which is path number B, and it is through an unknown mechanism. HMB is going to influence and positively affect the mTOR to which is going to lead to further phosphorylation of P70 and 4E binding protein 1. And that is going to lead to an increase in myofibrillar activity and an increase in protein synthesis. And those are going to lead to an increase in the rate of repair and increased performance, especially seen in athletics. Pathway C is also an unknown mechanism. However, there's a negative influence over there. The high concentration of HMB is going to lead to a blockage in the ubiquitin pathway. And that is going to lead to an increase in the activation of 26 proteasome, increasing myofibrillar action and an increase in, a decrease in protein degradation. And to that, there will be a lowered rate of repair and lowered performance. So when HMB is shutting down the ubiquitin pathway, there will be a lowering, a shutting down in the lowering rate of repair and lowered performance. So all in all, activating the mTOR and deactivating the ubiquitin pathway and the conversion of HMB to HMG coenzyme are all going to lead to an increase in the muscle mass and decrease in fat content. Just to clarify, in pathway C, there will be a depression of protein degradation. So the high concentration of HMB supplementation is going to lead to a depression or a stopping of the protein degradation through inhibiting the ubiquitin pathway. So throughout all of those researches, most of them were studied on a dose of 3 milligrams of HMB supplementation, but the efficacy of higher doses was not studied. So future research should be directed towards that way. And also optimal dosage of HMB under different catabolic rates was not also studied. And if there is any possible proteolytic pathways of HMB, and further research is needed in finding the unknown pathway in activating the mTOR pathway. So to conclude, HMB supplementation can be safe and it can improve several markers of health. 3 grams of HMB has been shown in all of the researchers included in the review in maximal benefit. However, this maximum benefit can be achieved only if exercise was there. HMB extensively can be used as an ergogenic aid and marketed for athletes. And HMB can inhibit the ubiquitin proteasome proteolytic pathway through the inhibition of intracellular protein degradation. And HMB can also be used to stimulate protein synthesis through either the activation of HMG CoA or the other pathway, which is the mTOR, that needs further studying. This is the reference that I use. Thank you all for your time. If you have any questions, please I'm going to include my email. Please send them to me. Thank you for your time.